Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So as people come and take a seat, we have a really terrific panel here. You'll recognize people from the previous panels. We have one addition, Richard Muller, who is the head of artificial intelligence research at Cambridge Semantics, Inc., and he's also a core member of the Future of Life Institute team. And Future of Life Institute has been a really terrific partner for us in organizing this whole thing. So we're delighted to have him here to join us, along with Shane and Percy and Jan and Tom and Nick and Cynthia and Andrew. So it's a great panel. Just as I get this open, what I thought I would try to do, while this is coming up, actually, one thing I'll mention quickly, for anyone who's looking to follow us on Twitter or perhaps might like to contribute to Twitter, we have a hashtag algorithms among us, so you can look for that. And the theme we're going to try to explore is which research directions that are interesting and concrete might we want to investigate to help ensure that we get beneficial outcomes. And I think that both Nick and Percy's talks really helped get us started there. But just to help us be able to stay a bit more focused, I'm going to try to define and highlight a few particular areas, which are areas which we can talk about, at least with defined terms. And what I'm going to do is I'm going to define these areas, and I'll ask each panelist if they might like to pick 3 of these that they think would be good areas for us to work on. Sorry, it's a bit hard for you to see them, but I'll read them out. After I've read them, please just take these as some areas which might be interesting, but of course you can add any areas of your own, and some of them we've touched on already before. So they're in no particular order, although they've got numbers. I'm sorry, again, it's hard for you to see them. The first one is what I'm calling here robust learning. So that's the idea of performing well in settings that are very different to the training environment, a bit like Percy was mentioning. So know what you don't know, or this includes ideas such as being aware of your context, perhaps alerting a user and switching to a safe mode when encountering an unfamiliar setting, and perhaps we could even work to provide a certificate of good performance irrespective of an environment, even if it's very different from that in which it was trained in. The next one is what we'll call interpretability or transparency, which has already come up. So this is the idea of understanding the reasons for an agent's predictions or decisions. This came up earlier in the legal context, thinking it would be particularly useful there, but of course might be useful in general. A third category is security. So that's protecting us or an agent against attack by a malicious agent. Also includes the idea perhaps of policing misbehaving agents, because if we want agents to behave a certain way, something we'll have to police those. A fourth area is verification. So that's ensuring that an implementation meets its specification. A fifth area, a very interesting one, is values. So this has been touched on before with the idea of inverse reinforcement learning. Perhaps we could learn values from people, but more generally, what values do we want an artificial agent to have, and how can we achieve a reliable implementation of those values? This area is sometimes called validity. Next category is control. That's come up before also. So how can we ensure human control over an agent, which potentially could include our ability to update its objectives or even to shut it down? And the last category that I'll mention briefly now is the idea of empathy or theory of mind. So can we make an agent anticipate human emotional responses? So the idea of that would be that perhaps it's essential for allowing reliable initiation of acts of kindness of agents towards us. It also may facilitate deception or even perhaps manipulation of humans by an artificial agent. And we may have seen acts like that in some recent films. So anyway, so those are just a few categories, and I'll start by asking each panel member if they might like to pick 3 of those or provide any other comments. Maybe we'll just go through in turn, perhaps starting with Andrew.
So let's see, sometimes it's tempting to pick a few directions of research and say everyone should do these 1 thing or 2 things or 3 things. I believe that it's healthy for research community to invest in multiple things and to make investments maybe proportional to the promise or the problem is divided by the uncertainty or something. So I think it's good if a research community does many things. Maybe I'll just pick out a couple that stand out as I think being very valuable. I think I'm also a co-organizer of the symposium on the other side as well. So I was there, I missed some of the earlier talks, which I apologize. But I think robust learning is one of the problems that faces us a lot today. There was an invited talk at ICML that talked about this too. But I think the biggest assumption of most machine learning is that with the same train and test distribution. And when you're on the front line shipping code, this just is so false so often, right? And a lot of work in real life is in making things actually work when your train and test distributions are dramatically different. I think security, we all know, is a major issue. I mentioned the earlier panel work on self-driving cars, for example. So we spent a lot of time obsessing about security. And one other area that I think is that, and I'll mention, you know, I personally at Baidu Research, we're not making huge investments in control, not because I don't think it's a good research area. I think everything is a good research area, but I just don't think of it as a significant risk for the near term. I don't think we'll lose controls of computers. But I think empathy, theory of mind, there's one interesting trend I'm seeing, which is emotional agents. So I'll give a couple of examples. In China, Microsoft, this is work by Microsoft, is a fascinating project called Little Ice, which is a conversational chatbot that talks to you. And in China, there are actually many users that when they're feeling lonely, you know, will actually turn to this chatbot for emotional support. You kind of form an emotional connection. You say things like, what's the weather today? And the chatbot would say, it's raining. Oh, and wasn't it hilarious when that celebrity was caught out in the rain? And it's really kind of a believable character. Another example, if some of you have children, there's a really interesting product called Toy Talk, which is a app that you can download for like a few dollars that talks to you. And it works better on children than on adults, but it has a kind of believable conversation. They'll ask you, what's your favorite color? Then they memorize that, and you know, like 20 minutes later, they'll say, oh, my shoes are, insert that color. You say, wow, we have the same favorite color. You know, it works better on children than on adults, but I feel like we're increasingly seeing, and just I was chatting with, I forget your name, someone who's from Pixar, who's developing emotional agents using machine learning as well. But I think having machines have deeper empathy for us is another area where I feel like there's a sort of a trend coming. So those are some of the areas that I find exciting.
Thank you.
So soon? Okay. So among the ones that you've listed, certainly...
Feel free to add also.
Yeah, I will. Certainly security stands out. I could just imagine somebody breaking in and changing the labels on our data for the cancer detection training algorithm, things like that. I mean, just horrible, horrible things could happen. The theory of mind and empathy. So first of all, this reminds me of ELIZA. I don't know if you remember that, but people used to spend a lot of time talking to ELIZA. In general, I worry about emotional manipulation. So for example, my advertiser is not my friend. And it's in my advertiser's interest for me to be kind of sad and depressed and hanging around and maybe shopping online instead of going out and doing something fun. So I'm concerned about that sort of thing. And that still, though, there are good uses to put technology that will help us understand our own feelings. Am I feeling sad? How do I feel about this really complicated thing that happened? How can I tease these feelings apart? Maybe there's something useful, but I do worry about manipulation. And just another thing is, I think that in general, we should be finding at least parts of values that are amenable to mathematical analysis and laying down some kind of theoretical groundwork and developing algorithms. So privacy is a big, big topic, but we were able to bite off a piece of that in the form of privacy-preserving statistical analysis and actually get somewhere. Similarly, for things like fairness, you don't necessarily have to come to judgments. I mean, there are two parts of the problem. One part is deciding what does fairness mean as an abstract. So one approach that we took in Fairness Through Awareness is that people who are similar with respect to a specific classification task should be treated similarly. Somebody else might say that people who are different should also be treated differently. What are the scenarios in which both of those things can happen simultaneously, and are there scenarios in which they just come into conflict with each other? And you can find examples for both. So, and I think that eventually we will have to do normative work on values, going back to our first panel, but just trying to set up a structure for where you can do that normative work, I believe has great value.
Thanks very much. Nick?
Yeah, I might say transparency, values, and control. I think some of the others are also very interesting. Maybe not so much the empathy, partly for the reasons already explained. But one criterion, I mean, it depends on what one is trying to achieve. But I think some of these others there will be a lot of research done on anyways, because there are, just from commercial incentives, a lot of reason to study security, let's just say, or robust learning. Whereas some of these others might be dependent on people studying them because they specifically care about what might happen in the longer term. So if that's your driving motive, you might want to go to the areas which will not be fully occupied anyway, and those might be among this list, the ones that I would pick.
Thank you. Just thinking about that theme on the empathy perspective, that is an area where people may be looking to develop that for commercial purposes, as Andrew's mentioned, and so therefore it may be worth doing additional work to try to prevent that from getting out of control. Does that make sense?
If somebody has some very bright idea for a specific approach to this that would differentially help with the control problem or getting a good outcome, then in principle, yes. I guess it's not clear to me what kind of work one would do there that would have this differential impact, as opposed to just coming up with shortcuts. Before you have the general intelligence to properly understand what human thinks and why, to come up with sort of clever shortcuts that make you fairly good at anticipating emotional reactions and then presumably using that for manipulation. It's just not clear that that's the highest marginal utility, like use of scarce resource dollars or brains that are concerned about long-term outcomes.
Thank you.
So I guess I'm doing work currently with some funding from the Future of Life Institute on the robust learning question. So obviously I think that's an important one. I think security and verification are very complex topics in this case. I mean, we know that machine learned systems are going to have a certain amount of error in them, and so I think it's quite challenging to say, well, how can we verify them? I think we really need to take a sort of adaptive approach where we build in very powerful self-monitoring, because I don't think we can guarantee up front. As Stuart Russell says, a proof of correctness of a system interacting with the environment has to include the environment in the proof. So there's a lot of bits out there, even more than was discussed by Percy. But yeah. So enough said about that. I think for values, Stuart Russell isn't here, so let me mimic him. Right? He has been pointing out that we have a vast corpus of cultural artifacts, plays, movies, books, that often hinge on moral and ethical situations, and we could use as a huge set of training data. Maybe we need people to label it, or maybe our natural language understanding can get good enough about what's considered appropriate and inappropriate behavior. And so I think that's an intriguing idea. I think certainly in the kinds of applications or the kinds of toy problems that we work on in the reinforcement learning world, no one really questions why does the mountain car want to get to the top of the mountain, or why does the chess program want to win at chess. But I've been doing a lot of work in ecosystem management problems where you have endangered species, invasive species, firefighting costs, human beings at risk, firefighters at risk. The reality is, of course, the real world is very complicated, and I think I sort of see this values bullet as an appeal to that we need to embrace that complexity and stop pretending that we can even encode it in a single scalar reward function. There's risk sensitivity as well, and I've been very pleased to see a lot of work lately in risk-sensitive RL. So I'll stop.
Okay, I'm going to go down, the list partly. Robust learning. So I think an important aspect, thing that we've learned over the last few years is that systems are more robust if they are trained on more tasks than originally planned. So, for example, we have speech recognition systems now that are trained to recognize multiple languages, and they work better on each individual languages by being trained on all languages simultaneously than if they are trained separately on each language. So it's kind of a form of transfer learning, or hints as it used to be called. So the more intelligent those machines get, the more different tasks that we train them on, the more robust they are in each individual task, because the more different situations they see, the more general their features or their representations are of the world. So that's in my sense how this is addressed. Another thing is that if we succeed in having some sort of what I was calling in the previous panel unsupervised learning, we might hope for machines to acquire what we call common sense, and that will give them an idea of how the world works and sort of allow them to infer a lot of things that are unsaid when we talk to each other. Okay, interpretability and transparency. This is something that a lot of people come to machine learning researchers. This is not specific about AI, it's more about machine learning, and say, okay, but don't use this very complex model because you're not going to be able to explain, it's not going to be able to tell me how, why it made that decision. So I want you to use this very simple linear model because now there is a weight, and the size of the weight explains to me how whether this particular feature is important. I always thought this was a complete fallacy. You can always make the desire to make the system transparent and explainable also, as a result, makes it bad, makes it perform badly. And so if we have to throw away interpretability for quality, I'll take quality. Security I'm not going to address because I think that's completely orthogonal, really. It's, security is handled separately in computer systems. Values, I think, is a very important aspect in the sense that in humans, the way humans behave is essentially determined by our reptilian brain. A lot of the drives that humans have are driven by our reptilian brain, and our kind of higher brain functions, if you want, interpret this in some ways that they make us achieve those drives more efficiently. But really the basic drives are kind of things that we don't control. The evolution has built us in such a way that we cannot really change what our basic drives are. Survive, feed, etc., reproduce. So we have to kind of build intelligent machines in the same way. So there is sort of unmodifiable drives that will be in line with human values. And it's not clear to me that requires a lot of machine learning in it. It's more like basic design and kind of solidifying this those things. And so we don't want to build the machines that have a high level of self-preservation that will kind of prevent us from controlling them, for example. Empathy, a theory of mind, of course, is part of that. So I think if we want machines to interact with humans properly, we need them to understand humans, and have access to human behavior and human values, understand human value, etc. That's, I think, something that some people actually are working on right now. It's very important if you have systems that are able to dialogue with humans to really understand, have a model of how humans interact with them.
So I'm going to answer this in a slightly roundabout manner by first trying to summarize and crystallize what the overall concerns are potentially in the first place. So there's enablement of these systems, there's confusion that these systems can have, and then there's potential acceleration of that confusion. So the enablement is the growing ability to have a much larger model space, a much larger world model. And potentially, it's not an explicit model, it could be just representation learning, but being able to have much better capacity to model the world. And then there's the action space along with that. So Percy was talking about the whole space of possible actions. When we're at the point where these systems are able to make phone calls in a realistic manner, have a conversation with folks, that can just be one possible action it can choose to do. It can also potentially start an LLC under an alias or something like that. It's not that difficult to do. These are just possible actions that it can do. The confusion, and just generally speaking, these capabilities are neutral. They're pure leverage, pure power, and generally we can make them quite good. The confusion comes in a couple of different ways. There's the values, which can potentially be not necessarily at odds with us, but just orthogonal to us. And then there's the control issue of that confusion as well. So if different aspects of the control points and levers of the system itself are included in the world model or the representational capacity of the system itself, things like being able to turn the system on or off, being able to control which inputs come at it, or how its reward is delivered, or how it evaluates its error functions, or cost functions, I should say. Those things all fall into that. So, and things like acceleration are these things that you may have heard of around superintelligence, around intelligence explosion. But we can kind of factor those out from the conversation, mainly focus on actually the confusion aspect. So looking at that, I would say values I would put at the first, if I'm picking kind of my top three. So this is things like computational ethics. This is a field which does exist today. It's rather small. I would say that we need much more investment in this area. I'd like to call out a specific project within this, Ethica, which is based in France. It's Ethica with 2 A's at the end. That's trying to be able to model different sorts of ethical systems in a single space. So things like deontology, things like different types of utilitarianism, things like value ethics, being able to have ensembles of those, being able to do computational differences on them, and being able to analytically and quantitatively express different ethical systems and model them and do different useful things with them. I would say control, going back to the fact that these different control signals can leak into this expanding world model. If we have, let's say, a home robot which knows how to plug itself in, knows how to go to the store, buy some milk, come home. Maybe at some point it turns a TV on and it watches a show and learns about itself more. It learns it can potentially take its charging base and take it somewhere else. I'm just kind of making this up on the fly, but my point is that once these control signals come into the picture and the world model expands to more than just the toy context that we've created for it, it becomes highly unstable and difficult to predict. And I would say the third is security. I think we need to completely expand our view of what that means, especially when we get to things like unsupervised online learning, where systems are able to kind of draw from the world and kind of build their own implicit representations and models, and being able to act on those in ways that are not necessarily clear as to what sorts of chains are within that. So I like to have this toy problem called the faux news prison problem, where a robot is put into a jail cell for 6 months, And all it has is a TV with faux news on. And it has to figure out which 30% of what it's watching is true and which 70% is false. So this is sort of an online learning problem, as well as a security problem. It's both in one. So what sorts of, whether ethical systems or biases or sets of biases need to be in that system originally for it to be able to do that differentiation successfully and not be compromised, not have its integrity of what it believes compromised.
Thank you. Interesting. Percy.
All right, so in my talk I already mentioned robustness and inferring values, or what I call specifications more generally. So I won't talk about those. I second Cynthia's worry about empathy and manipulation of humans, but I want to focus a little bit on interpretability and transparency. So I agree with Jan that just having a linear classifier, or let's say a decision tree, which is kind of the thing that people think are so interpretable, is actually kind of not really addressing the deeper issue. And this goes to what I said in my talk, that the behavior of system is really determined by the data, not really the models. So just because you have this nice, seemingly simple explanation doesn't really reveal the underlying reasons why you're generating this prediction. And I think, you know, the more general point is that it's about kind of having, you know, kind of a social contract of some sort. So, or maybe put another way, a user interface. It's kind of a user interface issue. So when we interact with each other as humans, we kind of have a model of, you know, what the other humans are going to, you know, do. So I think it's important for us to have models of kind of also what, you know, machines are, or AI systems are going to do. And so there, I think it's actually a pretty delicate issue where I think it's actually quite possible for humans to, or AI systems to give you seemingly nice explanations of your answer. But I think that's, I wouldn't necessarily call, I guess maybe that's interpretability, but not transparency, because I think that there's no kind of independent, objective truth to that. So imagine, you know, you're building a question answering site and you basically ask a question, let's say it's yes or no, and the system flips a coin and goes on the internet and finds some supporting facts and presents it to you. And this is great, right? It looks all interpretable, and you know, the internet says so, and you can call it personalized search too if you want. So that's a very bad scenario to live in. So I think I'm just kind of hinting at why the transparency and interpretability is actually kind of a deeper issue.
The first thing I'd list would be values. Human values and ethics, as I'm sure you'll know, is a very, very complicated and convoluted thing that's it's not particularly well understood in some cases. Sometimes it looks quite inconsistent. So I think that trying to, you know, if we want to create machines that have good ethics and values and behave well in this sense, it would be good to start if we have a better understanding of what our own ethics and values are. And I think our understanding is currently quite poor. One area that I'm quite excited about is the intersection between neuroscience and ethics, and using the tools of neuroscience to better understand how people make ethical decisions, particularly the work of people like Joshua Green. Another thing I would list, I guess it's sort of related to some extent to the verification, but it's a little bit different, is the idea of using sandboxes to study the behavior of intelligent systems in some sort of controlled simulation. I think we're going to have you know, incremental progress towards general artificial intelligence for quite some time, and as that occurs, there'll be a long period where we'll have fairly intelligent systems that at least, you know, generate some pretty interesting behaviors, but they're not, you know, not human level or anything like that. And during that period, I think there will be a lot of value in studying the behavior of these systems in controlled sandboxes and starting to understand how they perform in a wide range of different scenarios and investigating possible failure situations and seeing what happens and experimenting with different designs and so on. So I think there's quite a lot of sort of empirical study that can be done even with sort of moderately intelligent agents that are generating some, interesting adaptive behaviors. And the third thing I'd talk about would be formalization. In particular, formalization of some of the sorts of problems that, for example, you see in Nick Bostrom's book. At the moment, we have, sort of a philosophical analysis of various issues around the stability of goal systems and whether you can interrupt an agent or whether it's likely to be resistive to that, and all sorts of things like this. What I would like is for us to move from that into a more formal analysis where we construct more precise formal models, of very simple models even, of some of these problems, and consider theoretically, maybe even empirically in some cases, how actual specific algorithms would perform in these situations. It's something that we've been doing a bit of at DeepMind, and what we've been finding is that when you try to formalize some of these problems, you actually start to, and you really start getting down to the details, you start to realize that there are actually a few different variants of the problem, and some of these details matter. And furthermore, when you consider particular algorithms, real algorithms, reinforcement learning algorithms and so on, operating in these environments, you also start to realize that there are different algorithms behave in different ways. And so in some situations, there are particular algorithms and particular formalizations of the problem where you see exactly the kind of thing that Nick describes in his book. But there are other algorithms that are slightly different, and you don't see that at all. It might behave in completely the opposite way. So I think that's a general sort of direction I think we need to go in, and I think that's often how science progresses. I mean, first of all, the philosophers turn up, and they take on the really crazy, wild terrain where nobody's really even sure of what up or down is, or even what the questions are, let alone what the answers are. And then over a period of time, these things become more rigorous and formalized and studied theoretically and empirically in different ways. So I think that's some of the transition that we need to start embarking on in order to get more concrete and more reliable answers to some of the sorts of issues that Nick draws attention to.
Thanks very much. I know Andrew wants to respond quickly, but can I just maybe ask Shane, is it possible for you just to share one of those, just one small example to help make it a bit more concrete for people, what sort of thing you're thinking of?
So one of the things we've been finding is, trying to think which is the easiest to explain. So the behavior of some of the algorithms, when you look at their whether they're susceptible to changing their value functions and things like this over time, depends a lot on how you formulate their objective functions, and whether they're essentially valuing the future according to how they predict they will value the future, or how they would currently value the future. There's also important differences to do with whether policies, whether the agent is on policy or off policy. And these are sort of the technical differences that machine learning people know about and talk about a lot, but at least so far, well, particularly in the on policy and off policy, I don't really see that turning up in a lot of the discussion and so on. So I think that's just part of the process of trying to formalize these things. We also have a paper that should be coming out fairly soon on agent interruptibility, and trying to come up with a fairly precise and clean definition of the problem, so that you can start to analyze it in different situations and so on. It's a fairly difficult thing to try to do. It's quite subtle when you start trying to nail down what that means. But I think there are a range of things in this area where progress can be made, and I don't think that many people have really tried that hard. but yeah, over the coming years, I mean, we're not keeping this research secret. It's just not finished yet. But you'll see some of these papers coming out from DeepMind where we try to formalize some of these things and highlight some of the subtleties that we uncover as we try to nail things down more precisely.
Yeah, just real quick. I feel in some ways this is one of the strangest panels I've ever been on. Maybe 2 months ago, so my wife has been working on a children's novel. About 2 months ago, she wanted to use a test on some kids. So we're hanging out with a bunch of like 8-year-old girls or something, and we mentioned that, you know, I work on AI, optimistic about the progress in AI. And these young 8-year-old girls, they had the look of wonder in their eyes. Like, wow, computers are getting smarter? That's so awesome. And then you come to NIPS and you say computers are getting smarter? It's going to be terrible. It's so dangerous. So I think I don't want to be too naive about the challenges and the problems. I think earlier panel mentioned the challenge to employment. I think that's one problem. There'll be other problems as well, security and so on. But look at the bright side. I mean, let's take empathy, theory of mind. That was maybe the most controversial one. You know, some of you know that I'm also involved with Coursera, the online education website. It turns out that to finish a class today, it takes a pretty motivated, hardworking, self-directed person, right? It takes a pretty special person to finish those classes because they're hard work. So what do? We've experimented with badges. We've experimented with sending students email to bring them back. If we think they're discouraged, we're trying to find ways to motivate students. And are we trying to empathize with students? Absolutely. Are we trying to manipulate them? I don't know. That's a very loaded term. But to the extent that we can help people complete courses by empathizing with them, I want to do that. And I think that all of us in machine learning, honestly, NIPS looks big, but there's so few of us relative to the need in society for more machine learning talent. It feels like there's so few machine learning people that the tiny handful of us at this conference barely, frankly, not up to the task of all the things we could go out and create in the world. And I feel like machine learning is a superpower, right? The world today has so much data. Those of us in machine learning can design amazing things that no one else can build. And I think it is up to each of us as an individual to make sure that as we develop systems that can empathize with people, systems that are more and more powerful, that we be ethical and we do the right things. And I wouldn't do this thing. I know many of you wouldn't do these things if you didn't believe fundamentally that the work we do will make the world a better place. So I hope we can, you know, keep that and use our skills to make the world a much better place.
Thank you. That's an excellent point. I mean, yeah.
Thank you.
So I think part of it is sort of an engineering mindset. I mean, so the analogy I use is, so if you're an Apollo project, you're trying to put a man on the moon, and that's awesome. But if you're actually working on the project, you know that's awesome, and it'd be a really great thing to achieve. But you spend a lot of time thinking about all the different ways that rocket could go horribly wrong. Because you know that that's really important to getting the man on the moon. So you spend a lot of time thinking about how things could go wrong, and it doesn't mean that what you're trying to achieve is not really, really awesome.
I'd be shocked if there's anyone on this panel who isn't super excited about all the wonderful things that we think is going to come of this. But with superpowers comes super responsibility.
I have a comment about control. It comes back to something that happened 2 years ago at NIPS when Mark Zuckerberg showed up at the deep learning workshop. What he talked about was the fact that, in fact, the event that a super intelligence took over a slightly inferior one already occurred in evolution. So as I was referring to earlier, our brains have really kind of multiple modules, one of which is sort of the equivalent of the reptilian brain, on top of which the cortex and neocortex has grown. And to some extent, the cortex is subservient to the reptilian brain, which encompasses all the sort of primary drives that we have. And so Mark Zuckerberg described AI as sort of the exocortex. So it's kind of a even more intelligent entity, perhaps, eventually, but will be under the control of the neocortex itself, under the control of sort of the human reptilian brain. So it's sort of maybe a picture that we can keep in mind when we think about intelligent agents not being completely autonomous or independent, but being sort of extensions of our own intelligence, the way cars are extensions of our legs or something.
Tom, did you want to comment?
So I thought I might want to say a couple words about the empathy theory of mind thing. I mean, obviously you need theory of mind you can't understand natural language without having that. Just you can't really conduct transactions without that. But empathy, I think, is a very tricky thing and very fraught moral ground. I feel like that I should have a right to know whether I'm talking to a computer or not, to artificial versus a human thing. Now, maybe I am a humanist, I guess, in the sense that I hold like human life and human the quality of human life above any moral standing that a robot might have. I've been known to refer to robots as our slaves, and some people have an instinctive reaction like, nah, that makes me feel uncomfortable. Not me. That's I guess that's one thing. But and so my first reaction was genuine empathy, which is based on the fact that you and I are both humans and share fundamental human experiences of being born and growing up and our mother's breast and all these things. Those are experiences a computer is not going to share with me. Its empathy will be a false empathy in that sense, right? It will not be the result of genuine human experience. It could be an extremely good simulation, however. So I was troubled, found that very troubling, the idea that basically I'm being tricked, right? As Andrew was saying. But then I saw some video from the Institute for Creative Technologies in Los Angeles. Some of you may have heard of it. They have a synthetic human character that interviews injured soldiers coming back from the war who have PTSD, and they are more willing to talk about their challenges and open up to the synthetic agent, fully knowing it's a synthetic agent. There's absolutely no doubt. And the videos are really moving about how more effective the therapy can be when it's administered by, or it's it's just the interviewing that is being administered by the computer, and then a human therapist is then looking at that. But they learn so much more this way. So I'm really confused, I guess. And I think Andrew's example is also really good. It's clear that there are important, morally defensible uses of false empathy, if you let me use that term. And so I guess it's just back to our values question.
Good. Well, I think there is some possibility of having empathy with minds, even if you haven't shared all their experiences. And the stronger your capability, the more you can do that. So I wouldn't preclude the possibility that machines could learn to do this, even if they have a slightly different set of experiences than we do. I think one big problem with empathy, or rather with the word empathy, that keeps bothering me is that it kind of means two different things that often get rolled into one. So on the one hand, empathy refers to the ability to understand what other people are thinking and feeling. But then there's also the meaning where it means caring about what they're thinking and feeling. It really is better called sympathy, perhaps. And these two can come apart. And it's not clear that you want the former where the latter is absent. So say like a psychopath might be very good at reading into what people are thinking, and precisely because of that can be very skilled at moving people around to achieve their own ends. But that's a very different thing from actually being motivated by other people's pain and suffering. And I think that latter sense of empathy might potentially, if we could figure out how to do that, might be one potential approach to getting machine intelligence that is aligned with human values. I mean, you could argue about the pros and cons, but one possible approach. But just getting the former, something that is better able to predict what humans think and feel without actually being motivated to then act in the human interest, might not bring us any closer. So, but at a very minimum, we should bear in mind that when we talk about empathy, there are these two very different things that we might be meaning.
So no empathy without sympathy. Good. So maybe we can come back to values, which is something that almost everyone has commented on. And taking Andrew's point to heart, thinking about a positive, perhaps, if we try to develop values for artificial agents, maybe it makes us think carefully and even learn interesting things about our own values, which would be a great thing. So I guess we've a few people have mentioned the idea of inverse reinforcement learning. Are there humans out there who are good enough that we would be able to learn from their actions how we should behave? Or is that insufficient? And do we have to look at movies, as has also been suggested, and look at people's reactions to be able to try and infer how to behave?
You might be able to find negative examples too.
For sure.
Just look at the reactions to Trump.
Anyone else want to go?
Yeah, let me say something real quick about. So I worked on reinforcement learning a long time ago as well. But so in the self-driving car world, there has been a lot of debate about values, right? Would you rather veer off the road to kill one person in order to not hit a truck full of 10 people, whatever? All these ethical debates, and people meet about it, debate about it, endless. A lot of research papers and so on. I feel like, speaking as someone that is actually working on self-driving cars, I feel like this debate is fascinating. We definitely follow and we definitely pay attention to it. But in terms of what's needed to improve the capabilities of our cars, this is so far down the list, right? Because realistically, a lot of the problems we face are more, how do you see the car with high accuracy to just not hit the car, rather than these moral, ethical dilemmas that we like talking about. So maybe this is overly short-term thinking. Maybe we're to look ahead 10 years rather than only 2 or 3 years. The values becomes more of an issue. But again, speaking as someone, actively shipping a lot of code to a lot of products, it hasn't become important yet, but that's not to say that it won't become more important.
Just one comment about values, I guess. I mean, I guess people have talked about possibility of, looking at mining, human text or looking at what humans are doing. And I think fundamentally that won't be enough, because I think the hard part is not determining these, proverbs that you can read off. I mean, they're there, right? The hard part is actually knowing in these specific situations kind of what to do. And the amount of data for that is just very sparse. I think values matter when you're not on a day-to-day basis, but it's in these kind of extreme situations. So I think a historic data-based approach is kind of, I don't think is very promising. Now, what you could do is perhaps, still try to elicit things from humans. So you can construct scenarios and ask people questions about them. And in a kind of adaptive way, try to elicit kind of what the community kind of thinks. And you also have to be a little bit careful, like who you're asking and how do you, because you're going to get a distribution of results and what do you pay attention to. But fundamentally, I think the point is that I think you have to look at, be more adaptive about it rather than just get a bunch of data and hope to train something.
I'd just like to mention some extensions to inverse reinforcement learning about looking at large ensembles of people's behavior, not just a single instance at a time, and being able to try to infer what it is that they actually want to do as opposed to what it is that they're doing. So I think that there's some exciting research there. I think Stuart Russell might be giving a talk pretty soon about meta reasoning, and that's quite related to this. So check that out.
Going back to values, I think there's something to be said for values and sunshine. So you were saying, giving as an example that you could see how people feel about things. It would be interesting to make that, to expose that. And the best we're ever going to be able to do is sort of as good as society can currently do. That sometimes exposing very clearly and starkly how people are behaving or how the society values things can lead to a change.
But I think it is an interesting observation that in every field where computer scientists go in and try to build something, it immediately calls up the question of how do we evaluate how people do it, right? And this just happens over and over again. I'm working with people that are working on trying to reconstruct the tree of life, and they're trying to score the characters of fossils. And evidently they treat their published scores as completely correct. And we walk in and say, well, so like what metric do you use to decide that? Like, well, someone spent their entire career, they wrote this book, it's right. And that's just, we can't Okay, so I wrote a computer program. It produced a big score set too. We know that's not right. So it is. I think Paul Cohen at the DARPA Wait What conference this summer really said, when we're he said when we're building AI systems, we're really building a mirror and looking at ourselves, and it calls up all the questions we have about our own behavior, what we consider is acceptable for us. And so it's not surprising that that this is a very, very difficult thing, and we do need to try to formalize it. But I'm enough of a data guy and a machine learning guy to think that the formalization is going to be really way too simple, and the reality will be a lot more complex.
So I'm going to go off topic a little bit. I want to mention one other topic with Adrian's permission, which is unemployment. I mentioned earlier on the earlier panel that I think one of the major challenges that AI causes, frankly, I think a bigger challenge than the risk of unethical AI is the risk of unemployment. Eric, did you give a talk just now? No.
Yes.
Okay.
First session.
Okay, great. All right, so hopefully you heard Eric's talk, but I think that there is a huge economic incentive for us to automate a lot of work, and I think that there is a real risk of creating employment to the massive scale. Where is most of humanity employed, right? They're not doing research and development. Most of humanity are employed at the endpoints where they touch physical stuff. So manufacturing, customer service, and those things, a lot of those will be automated away. And I think that there is actually important research to be done. Maybe not, I don't know if it's machine learning research, it might be economics research or government policy research or something to figure out a new social contract. How do we organize society when so much work can be automated? And I think there are a lot of challenges. A lot of people like to say that education is the solution. I think that education is a major part of the solution. Based on the work I've seen in education, I actually am a firm believer that almost anyone can learn almost anything. So if there's an unemployed truck driver, because self-driving cars put them on a job, I think we can train them to be a computer programmer. But I think the other challenge that faces us is that if you have 30 years of experience in truck driving, and if your skill set suddenly becomes not valuable at all, then you'll be competing on an even basis as a 20-year-old for wages. And so whether a 50-year-old with 30 years of experience will feel emotionally okay earning the same wage as a 20-year-old, I think that's an example of the challenge we have to accept. I think there are important questions about basic income or negative income taxes. I think economists can have very interesting debates about whether basic income, we just pay someone money just for their being a citizen, or negative income tax, which maybe creates a better incentive to do work, whether that's a better solution. I think our society today is not, there are strong political winds against these things. I think certain parts of society emotionally feel that it is not okay to pay these people not to do anything, even though it might make sense. One other solution that I think we should consider is to pay people a basic income, but in consideration for studying, right? So if you're unemployed, we'll pay you, but you have to study in the hope that your studying allows you to re-enter the workforce at some point. I hope that all of us together, right? We are the ones creating the technology that will create some of these societal impacts. I think all of us, as well as people in government and people in economics, people in policy, can start to, frankly, run experiments or work with small groups, work with cities to try to figure these things out.
So I guess I can't resist the opportunity to be more Panglossian than Andrew. Yes, unemployment is bad, but it's also pretty good that we don't have to do all those things. The reason you have to pay people to do them is that usually these things are not fun to do. Otherwise, people would just do them for free. And so the fact that we can get machines to take care of a lot of this stuff is prima facie a great thing. Yes, one has to then make some adjustments. And that kind of, I think there are two components to that. So on the one hand, one reason we want jobs is we need income. So there's a monetary thing. But by definition, all of these jobs would be done anyway, so there's a lot of wealth in society, and it's just a matter then of finding, there's a matter of finding a formula that would enable, maybe through guaranteed minimum income or some other scheme, people to have some sufficient share that they are not wanting for material ends. And then the other part is meaning. So a lot of the reason why it's tough to become unemployed is that it makes a lot of people feel like they are losers. They lose their social context. They don't feel like they are contributing. So there too, there is a big challenge. We would have to sort of rethink our attitude to work, not as something that you do because that's the only way to be a valuable human being, but as something that has less and less need to be done. But that also should be feasible. Throughout history, there have been groups that have not had to work for a living. There are aristocrats. They developed hobbies and sports and hunting and interested in art and gossip and all kinds of things. Kids don't work for a living. They seem to have a good time, many of them. Some retirees find meaning in golf or whatever. That would have to be some cultural adjustment, but that's more like an opportunity, I think, rather than some horrible sort of dark cloud that is hanging over us. So, I totally agree with what you say about the car as well. I mean, I really can't get worked up about car ethics. It's just, but I just couldn't let the opportunity slip to actually be more optimistic than you about one issue.
Yeah, Jan, did you want to add something there? No, is that? I think we should applaud Andrew and Nick for being so passionate about these issues, and clearly they are long-term issues for technology. Perhaps I might suggest that it's a great responsibility on our community to inform a discussion on this in general society. I don't think this is an area where we're going to be able to resolve it just among ourselves, but absolutely we should be helping society to think about these issues, and with Eric and economics, politicians and everyone else. So it's a very important issue. Anyone to add something to it?
Yeah, actually, I'd like to surmise that the advent of AI is not going to have a qualitative effect, change or revolution on the general progress of technology. I mean, it's always been the case, going back 150 years or more, that technological change obviously displaced jobs. Societies have reorganized themselves. There's been powerful forces that have actually torn the planet apart that revolved around how you redistribute wealth, right? I mean, the emergence of the Gilded Age and harsh robber barons and harsh capitalism in the late 19th century, which created communism, which basically set the stage for the first half of the a good part of the 20th century. So those have very important consequences, choices that we make about how we organize society around the economy of societies. But I don't think AI is qualitatively different. It's just it's another stage in progress in technology, and is going to displace jobs just as every other technology has done in the past. And we will have to deal with this. It's not going to be easy, but not any more difficult than in the past.
Richard?
Well, so I'd just like to say that when we think of far future AI, it's not going to be very similar to these narrow sorts of AI that we have today. So it's really going to be quite cross-contextual. So that's why things like control become much more of an issue compared to just societal organization or things like that. If these systems, we can think of it as a multi-agent system, where there's a controller and let's say a tool agent. And if the tool agent is able to just vastly increase its modeling capacity and is able to essentially see a lot more than the controller, then it can do things that the controller just has no conception of. And at that point, because it's so cross-contextual, and because we will have been so reliant on it, we will have, quote unquote, lost control of it. So that's why, just kind of bringing this back to the more distant future, as opposed to these kind of nearer-term concerns around economics. I'd just like to kind of bring it up and say that there are some potential approaches to addressing this with combinations of potentially verification and game theory and potentially mechanism design, but that is, of course, research that needs to be expanded.
So humanity has quite a lot of experience with organizing intelligent agents so that they are controlled in a way. That's kind of called organization of society. We are intelligent entities, and we have managed to, at least in some cases on the planet, to organize ourselves in such a way that there is synergy behind, among what we do, and things are not going completely out of control, even though we as individuals have a lot of power if we want to. So it's not a new problem either. I mean, we'll have other types of intelligent entities roaming around, and we'll have to figure out ways to organize them the same way we organize society today. It's not going to be the first time that you have, mildly intelligent entities being in control of considerably more intelligent ones. I'm thinking about, politicians versus scientists, or something. So, we've done this before. It's a new kind of intelligence we'll have to deal with, but it's not qualitatively different.
I want to add just Jan's early comment about the change not being different than before. It's true that society has always, technological change has always caused unemployment. I think one thing that could be different this time, and I think Eric and Andrew McAfee explained this one there in their book, is potentially the speed of the change. So for the United States to go from primarily agriculture to now under 2% working in agriculture, that took over 100 years. What that meant was that if you're a farmer a few centuries ago, and as farming jobs were going away over the course of about a century, you could probably keep farming until you retired. It just meant that your children couldn't be a farmer, so your children had to go to school and go work in the city. And that was okay, because the farmer could keep farming until they retire. The children had to learn a different job. But with today's economy and the internet and how good we are at developing innovations and scaling them so rapidly, I think we are in a situation where a lot of people are trained for one trade. More and more people are trained for one job, but they're not allowed. They just cannot keep on doing that job until they retire. And what that means is that we're going to have people, in their 30s, 40s, 50s, and so on, whose jobs are going to go away before they can retire, and they will need to be reskilled for new positions. We as a society would never manage to organize ourselves well to reskill adults at scale, right? We've organized ourselves pretty well to educate children, teenagers, maybe teens up to the 20s at scale. We've never managed to organize a society to take huge numbers of people in their, late 20s, 30s, 40s, and 50s and retrain them for their jobs that have gone away. So I think that's the challenge that we face.
Percy or Shane, do you want to add anything there?
I was just agreeing.
Okay.
Very well put.
Very, very good. So I wonder if I could take a couple of the themes we've just had. We've talked about control, and a little earlier Tom was talking about how in some ways, perhaps as humans, we overestimate our abilities in some ways. So one idea is that even if perhaps we're using tools, we're using machines as tools, perhaps it's a bit naive and insufficient just to think about us controlling them. Perhaps it's more of a systemic thing where there's a sort of combination of all together, there's something that's going on. So for example, maybe if we're using some sort of news service which is pushing certain news stories in our direction, they may alter the way we feel about things and may lead to changes in our behavior. And so is it a sort of joint system issue?
To some extent, that's happened already. People talk about it as the filter bubble, where you only hear the point of view that you already like. Deirdre Mulligan and I have been talking about trying to build a dissonance engine that would introduce some well-chosen pieces from the opposite point of view.
Yeah, I don't know that I have anything to add to that. I guess, but it's certainly the case that these feedbacks get set up, and we know that this even happens inside our machine learning systems, right? And we've been learning this recently. And so I mean, Leon Botu in his talk at ICML this year showed how two machine learning groups in a company could both think that they were doing beautifully when in fact they were just learning to basically predict their own predictions, and not surprisingly, they were doing very well at that.
And perhaps this isn't a new thing. So with Andrew's aquaculture theme, some people like to think that we've done a great job of domesticating cows, for example. Whereas some people might say that cows have done a wonderful job of domesticating us to produce lots of them and take over lots of the planet for their benefit.
Well, and maybe that is a path forward. I mean, as I mentioned in the first panel today, I think it's very intriguing to think about how an AI system can be coupled with a person to make the two of them together more effective than either one could be alone. And that is surely going to be a co-evolutionary kind of process. So in the end, well, I guess maybe this is more thinking about the cyborg future rather than computers and people as separate entities. I don't know whether we're physically bonded, but we might be, but we're informationally bonded already to our phones. So.
Maybe I'll just reemphasize, as I mentioned in my talk, I do think that already we have this system where basically AI systems and humans kind of intertwined. And I think, and I think of the issues there in terms of control and how do you guide society and AI in a good direction are I think very much the same ones that you would probably have to deal with in the future as well. So I think maybe one other thing I want to just emphasize again is that it's important not to anthropomorphize. I think when we talk about AI agents, we think of them as kind of separate things that we don't really interact with. They come to us, knock on the door, and then we have to do something. But it's actually just all among us. And so I think we should just, by dealing with the systems and making them kind of more more robust and transparent, I think that'll give us the right techniques to deal with more advanced systems as time progresses.
So I'd just like to mention that it's not necessarily even agents that would have this sort of property. It could be what might be called an oracle system or simply like a very complex question answering system that might just implicitly, as it is essentially giving answers to people about what they should do or facts about the world, it can be influencing, not necessarily out of any specific intention, just by these emergent dynamics. It could be influencing them to, let's say, whether give it more resources, give it more data, things that would affect the world in some way. So I just want to say that these control points and these sorts of aspects of the codependency there is not necessarily only in the agent context.
So one possible sort of background assumption that might make a difference in how one approaches this is what one thinks happen next. So are we trying to plan for a period of time where we have roughly human-level AIs that can do a lot of jobs, maybe not quite all, and there are these humans that eke out some income from government subsidies, and we're still spending more and more time playing games or whatever, but we're still sort of two-legged, featherless creatures walking around. Is one trying to think about the longer term, where presumably this will not be the final stage of affairs? Like more and more of the mass, more and more of the action will migrate into the digital realm. More and more of the sentience around will be digital, presumably in a wide class of scenarios. So more and more of what matters will be what is going on inside these computer systems. And that's not going to end once we reach sort of roughly human level AI. It's presumably going to go way beyond that, and maybe then colonize the universe using self-replicating probes and filling up the accessible parts of the universe. And the action there is just vastly larger than the action here on this planet. So if one is thinking about it in this way, which I mean, actually, I think that's probably a more realistic view about the really long term than the idea that for the next few billion years we will sort of walk around on this planet. And so then one is really, I think, drawn to think more about how can we set up the initial condition. If there's going to be this momentous transition, maybe in this century, maybe in the next century, where the action moves from a biological substrate to a machine substrate that will then shape the disposition of the accessible parts of the universe. Are there things that we can do to set up the initial conditions in such a way that we increase the chances that this massive process will lead in some kind of desirable direction. And then some of the things that might look far-fetched, if only viewed within this kind of medium-term prospect, that just like strange thing for somebody to be thinking about. Some of those, I think, make more sense if one is really trying to think about this very long-term end game for humanity.
So one fact that we have to realize, which is independent of whether there is any significant progress in AI, is the fact that just because of the progress of computer technology and storage and communication, the amount of data that's being collected and manipulated by machines is growing exponentially. And the transformation of this data into knowledge is done mostly by machines. And the growth of the number of brain cases on the planet is not growing exponentially at the same rate. And what that means is that there's going to be a point, perhaps it's already passed, where most of the knowledge in the world resides in machines, not in brain cases. We just have to live with this. That's just a fact. Regardless of whether we make machines more intelligent, just if we use dumb machine learning that we have today, it's a fact that's going to happen.
So another question from the audience, and this may have to be, sadly, our last question. Could the panel discuss how they think about the trade-off between effectiveness and safety of algorithms, or effectiveness and interpretability?
Well, I'll come down very much in favor of effectiveness over interpretability.
Back in the old days, which would be the late 80s, there was a lot of work in expert systems, and and there were several startup companies, and every company had a bullet about interpretability and explanation. The reality, though, was that no one used those facilities when they were built into the systems. The question was, if it works well and all's going well, you don't need to know why. And it was ultimately primarily used as a debugging tool for the software engineers, not as it wasn't a question of acceptability to end users, that the system could explain itself. It was more for system debugging and repair. Even having systems that essentially told lies about, even though they're using some complex process, just pulling out like the highlights of a long chain of reasoning, or say, pretending you're linear when you're not, and just showing some weights. In experiments that my colleagues have been doing on document classification, they're finding that is sufficient for purposes of communicating like the main idea, the first order signal about why the system is working, and enough to elicit corrections from users without them having to correct the true code, right? You can give users a view of the system that's simplified if it is actionable to them to make the improvements they want. So I think, I would also agree that transparency, interpretability is some very weird thing. We like to talk about it a lot, and maybe in the forensic case, in the law case, it will be an issue. I don't know, but certainly the lessons from the past have been nobody cares if once the error rate is 1% or whatever, it's just great, and no one needs the tool anymore.
So I think it depends a lot on the application. So if it's some little game or something or other and it works really, really well, then being able to interpret what's going on inside is maybe not so important, and that's fine. But if it's running a nuclear power station or something or other, then you might be a lot more concerned about the reliability of it and really understanding, not just empirically that it seems to be doing the right thing when you did some tests, but really understanding and convincing yourself that it's going to be very, very reliable and not do anything unexpected. So,
but at a cost of the reliability itself? I mean, you just...
Well, if you're not convinced that you really understand what it's doing, maybe you shouldn't be firing up your nuclear power station and getting it in control of it. I mean, it's...
The nuclear power station it's an interesting example. I'm going to stay away from it because I haven't heard any discussions about that. But I have heard a lot of discussions about using artificial intelligence in medical contexts, for example, in predicting which patients are going to have adverse cardiac events. And study after study seems to say that the machines are better than the people even though it's not quite understood how they're working. I want that. I want the better prediction, the best prediction I can get now.
Sure, so that may be a case where the performance of the algorithm is tantamount.
Right, and there are many.
And understanding exactly how it does it may not be so important if empirically you can show that more people are surviving. So I think it depends on the nature of the problem. It's not so straightforward.
I mean, I think that if the trade-off is between effectiveness and interpretability, well, if it's effectiveness at achieving what we wanted to achieve, then yeah, we'll go with effectiveness. But in the context of, say, machine superintelligence, we might be unsure at the outset whether it will be effective at doing what we hope for it to do, or whether it will just be effective at achieving a different end. And in order to convince ourselves that it will actually be effective at achieving human values, we might benefit from being able to understand how the system works. And that's why I think interpretability and transparency is like a useful thing to be able to push on.
So I was going to comment on effectiveness is kind of, I mean, no one has really defined it, but I think the implicit definition that people seem to be using is test error on some held out set when people are talking about 1%. But somehow this is a crazy thing, right? I mean, if you told me that you had a black box that got 100% accuracy on all inputs, then I don't care how it works. I don't care about interpretability. That's fine. But that's never going to happen. So you could say, well, 99% is pretty good. But I think there's something that is kind of distributions kind of lie sometimes because you're going to deploy systems that work in different distributions, and maybe all your examples come in that 1% or something, or adversary drives all examples at 1%. Then now suddenly you have maybe like 80% error. So I think you have to be careful about what you mean by effectiveness, and I think average error over some set does not really count as a good definition of effectiveness.
Yeah, I agree 100% with Percy. In fact, I want to elaborate with a couple of examples. So let's say you're trying to build a self-driving car, and you want to go, maybe 1 million miles between accidents, right? So that's a clear test metric. It turns out really, really hard to drive a car 1 million miles to test it under all conditions, especially with the seasons, different countries, blah, blah, blah. So what do you do? And in fact, we have a similar problem today in today's aviation industry, right? You just do not fly airplanes IID or whatever to measure the test rate to prove that it's below the acceptable threshold at which airplanes can crash. And this is why interpretability of these systems adds an extra layer of safety. To the extent you can understand the airplane, define a protection envelope around the airplane, around the car. So you can drive a car for maybe 100,000 miles, but no other car ever comes within 5 centimeters. And this is actually what happens to airplanes. You fly airplanes, prove certain safety guarantees under very strong assumptions, show no other airplanes comes within a certain distance, never mind crashes, and all of these are sort of interpretability things that help us to do better on the metric we really care about, safety, which is very difficult to measure. One other example, search engine. We have our metrics for measuring the quality of web search, but sometimes if a user issues a query, maybe an important query, like a navigation query, I want to buy plane tickets, they just expect you to get it right. But if for some reason we get an important query wrong, and if the output of a neural network is very difficult to go in there and debug what's going on. I think earlier generations of search engines were more interpretable, actually. Someone could look at it and say, oh, that's a linear function, I need to tweak that coefficient and we can fix this query. And the reason we need to do that is because a lot of the metrics we use for measuring search engine effectiveness, let's say, is like an average over a pool of queries, but maybe the simple average isn't the best metric because there's some queries we just cannot get wrong. Users just expect you to get it right. So I think that both of these are examples of where really I think the broader phenomenon that Percy described of where you have a metric that's an imperfect metric, or you can't, the metric isn't really exactly what you need to optimize because we can't measure it well, don't have enough data, or we just don't know how to write down the right metric. Then I think there are cases where interpretability helps us add that extra layer of protection or performance around this metric. Having said that, I also agree with Cynthia that in the past many years, in the past 5-6 years, past decade, effectiveness has been so effective that I think that has largely trumped interpretability. But I don't think it is a 100% 0% thing. I think the truth actually falls somewhere in between.
Well, so maybe we're stumbling over the word interpretability, because what we really want is that the systems are highly reliable, so that we can have high confidence in them, and that could be under the adversarial setting, and certainly that's very similar to the kind of stress testing that you put aircraft through to make sure that they'll be able to take twice the designed load, expected maximum load in use or whatever it is. And so I think we need a lot of research on exactly how we could get high confidence in a machine learned system, because we know our current systems don't deserve high confidence. And it sort of comes back to Percy's question about, well, what is the spec, and what are the things we want, and maybe also maybe general principles of robust design. Jan was mentioning, it's kind of interesting to go back to the really early days of AI, back in the 60s when Newell and Simon wrote Human Problem Solving. I guess that was 72, but they have a whole chapter there about the trade-off between generality and specificity, and I think they would be absolutely stunned to hear that, because they believe that there was this fundamental trade-off that you would only get high performance by having very specialized knowledge and specialized algorithms. And that if you want a general purpose, you'd have to give up on high performance. So they'd be absolutely blown away by your language result. So hopefully they're rolling over in their graves right now.
So I have a quick question, which is, what exactly is the definition of interpretability? We have a gut feeling about what it is, but in fact, it's not very interpretable. There's that.
So I have an answer. It's whatever satisfies the person who asked for it.
Oh. So sometimes
you?
You don't want to know quote unquote why, but you want to know what's a short path to a different outcome. You turn down my loan application for my small business. I don't really want to know quote unquote why. What I want to know is there some relatively inexpensive path that I could take? Maybe take a bookkeeping course at community college or something like that would have caused you to give me a different answer. Those should be pretty. I think that's a really interesting direction for research, getting back to the research questions.
And one kind of distinctive version of this that will only rise down the road is, say, the mind detection problem. So you might be concerned about what happens inside the box because you care about what happens inside the box, not just insofar as it affects the world outside the box, but because there might be morally relevant agents inside the box. Just as you might care about whether you're buying from a company that uses slave labor, let's say, or have like sweatshops with kids. Even if the product is very reliable, now you might care about how that product was produced, and that might arise even more so when you have, say, machine minds that have sentience, and then you might want to be able to have transparency so that you can make sure that there is no part of that system, no submind, no component in there that is suffering in an unacceptable way.
Do you really think there's a little homunculus in there that is suffering?
I don't think that there is today, but I think that there will, be minds in the future that until we have a clear understanding of what the criteria for sentience is, it would be rash to just assume that there wouldn't be sentience in there, either the thing as a whole or different parts of it. This, I think, depends all on the particular architecture that we're looking at. I can imagine ways of building systems that would have sentient processes in them, and maybe other things that are simpler, that don't have that kind of structure.
So that actually brings me to a reaction to something that Tom said. You were talking about the people with PTSD who were responding well. And I think that this tells us something so interesting about humans. And I'd love to see a lot more understanding of what it is that happens to us when we communicate that causes a beneficial reaction. I think it's an extremely moving story.
So maybe Tom, just hear from you, and then Percy, and then I'm afraid that'll have to be it.
So in fact, we've seen a lot of the work in the AI community where it seems people are so willing to treat a robot as a companion, as some sort of quasi-animate object. And I feel like that's a bug, that's a side effect of the thing that we've evolved to be very cooperative with each other. And perhaps it's a bug we need to to think very carefully about exploiting in the research community, because I mean, you can see that the entire industries have been built up, say, gambling industry, drug trade, over other bugs that we have, and I don't want us to be another one of those industries.
So going back a little bit to the definition of interpretability. So if it's really as Jan defined it, then I don't really care about interpretability, because I think I think there is some property. Maybe it's transparency. Let's define it as transparency. Some kind of grounding to truth, and I think that's important because for example, if you're getting an email and it gets marked as spam, I kind of want to know some reason. I don't want you to show me the weights of a linear classifier. I just want to have some explanation of why these things are happening. And so I think of it as it's a continuum. I guess I think there's something important about reporting true facts about why you're about the process by which your prediction was produced. And maybe that's saying, even at the, going back to the data issue, maybe this is because your classifier was trained on this type of data, and that's why you got these predictions. Even knowing the data source, I think, can reveal a lot about, why something happened.
Thanks very much, Percy. Let's continue maybe afterwards, but please join me in thanking our panel. Wonderful discussion. And finally, we'd also just like to end by thanking our sponsors. So the Future of Life Institute, that's been a great partner to us. Baidu, thank you very much. Center for the Study of Existential Risk at Cambridge and the Future of Humanity Institute at Oxford. Thanks very much to everyone.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.